So here's how this is going to play out. So this is a 3-day lab final, and realistically, if you work at all smartly in class, you can just get it all done in class. Okay. Now, if you're worried about being stressed, and like, oh, I want to make sure I have plenty of time to get it done, you can work on the questions outside of class and stuff like that. But I don't set this up for you to have to spend hours outside of class. Okay. If you work efficiently, you can get this all done in the time that you have. So I don't want you to think, oh my God, I got to spend like 12 hours doing research. That's no, okay, no, okay, no. Set this up to be a little fun, a little challenging. So a couple of things about what I gave you. The first thing that I want to go over is the green sheet, okay? So this basically says, hey, this is how I'm going to determine your grade. And there's 4 parts to it, and this is what you're going to have to hand in. And so the first thing is a statement of purpose, okay? So and this has to be typed, and this you're going to do on your own. So everybody's going to write their own statement of purpose. So the statement of purpose basically says, hey, Burkamp, I'm going to explain to you that I understand what's happening in this lab. Okay? That's what you're going to do. And you've got these words listed: velocity, acceleration, potential energy, kinetic energy, projectile. So you're going to form those into some type of 2 or 3 sentences. Like, this is not a 5-paragraph essay. I don't want to read that much. Okay? Basically, you're going to say, hey, here's what we're faced. We're going to use this, and we're going to study this, and we're going to predict this. Okay? 2 or 3 sentences. Okay? That's it. Type, underline the words. Okay? So that's the first part you're going to do. And that you're going to do on your own. Now, the second part is the problem-solving strategy. Okay? This you will do as your group. Okay? You only hand in 1 per group. What this equation is going to do is allow you to predict where this marble is going to land. Okay? So you only hand in 1 per group. After I show you the demonstration, this will make more sense in terms of what you have to do. Okay? So that you're going to do on your own. That you're going to do as a group. But you want to make sure that everybody in the group understands that equation, because you're going to have to use subsections of that derived equation to answer some of the questions later on. Okay? So the worst thing that can happen is you let one person come up with that equation and nobody else understands how it works, because everybody in the group has to understand that. So in terms of how you hand this in, some people just write it very neatly on notebook paper. It does not have to be typed. So if you have someone with very neat handwriting, which excludes Tanner, and they want to, I'm just telling you, okay, do not let Tanner, if Tanner's in your group, do not let Tanner write the derived equation. Okay, I'm just telling you. He can help you derive it, but don't let him write it. Okay? So, just telling you. So, or you can type it out if you want to. Some people will do it on poster board, and they'll make it look very fancy. Okay? They'll even but don't use glitter. I've drawn the line at glitter. Don't use glitter. Some groups they bought like a tie, and they wrote it on a tie. Okay? Some have done it on coffee mugs. So you don't have to go to that extreme. Okay? But at the end of the day, and like I said, we'll talk more about this, what this equation is going to allow you to do is predict where it's going to land. Now, the third part is implementing the problem-solving strategy. So what's going to happen is that, and you'll see this in just a second. So basically, you're going to have a marble that's suspended between 2 strings. You're going to have a razor blade. It's going to swing down. The razor blade is going to cut the string. The ball is going to come out here, and then it's going to land on the floor. So what your equation is going to do is predict where the ball is going to land, how far it's going to travel. Okay? That's the whole purpose of this lab. So what's going to happen is that out here on the floor, you're gonna put a piece of paper. And you're gonna put an X that says, hey, this is where we think this thing is gonna land. Okay, cool, it's nice. So what's gonna happen is that you'll put a piece of carbon paper over the top of it, and that's like what we used when we did that projectile motion lab, and we rolled a marble down the ramp, and then it went out and landed, and we put that piece of carbon paper on the top of it. So you're gonna put a piece of carbon paper over the top of it, and then what's gonna happen is that here's your piece of paper, here's your X, and I'm gonna measure how far your mark is from the center, okay? And that's going to determine your grade on this part of it. So basically, if you're 1 centimeter or in, you're going to get 20 out of 20 points, okay? If you're 2 centimeters with between 2 and 1, you can get 16 out of 20. If you're 3, you're going to get 12. If you're 4, you're going to get 8. If you're 5, you're going to get 4, okay? So basically, the closer you are, the better off you're going to be. So you can do as many trials as you want, okay? You can drive your equation, set it up, come in, boom, light it, see what's gonna happen. It's cool, okay? You can do as many practices as you want. It's unlimited. The only thing you're constrained by is time, basically. Now, when you do what we're gonna call an official trial, so you're gonna do an official trial, you're gonna call me over, you're gonna go, hey, Mr. Burkamp, we're ready for an official trial. So what's going to happen is that you will put an absolutely brand new, pristine piece of paper on the floor. Okay? Brand new. No marks on it. You're going to put a single X on there. And you're going to call me over. I'm going to verify that it's a clean piece of paper. We'll put the carbon paper over it. We'll kick the tires, light the fires, have the marble, boom, there it goes. Now, if your group lands within 1 centimeter on that first official trial, you're done, okay? You don't have to do the rest of it. If you're not happy with that and you want to do the second trial, fine. I will take the best of the 3 trials, okay? So let's say your best one is your first one, and the other 2, not so much. I'll take the best of the trials, okay? So where the potential for extra credit comes from is that the group that is closest to the mark out of all the groups, everybody gets 5 extra credit points. So that's why it's actually potential for you to get like 105 out of 100 on the test, okay? So it's a little bit stressful, it's a little bit of competition. It's like, ooh, how'd you guys do? But that only counts on official trials, okay? If it's just a practice one and you like land it right on the mark, hey, happy for you. It's not an official trial, it doesn't count. And that's what everybody asks. Say, has anybody landed exactly on the mark? It's happened one time where they landed exactly on the mark. It was Mitch Voth, class of 2000, no. I have to go back and look. It's been a long time, okay? But probably before you all were born, okay? Those last time it happened where someone landed exactly on the X. Okay. So then, there's that. Then you're also going to have, last part of it, and this is, obviously that's going to be a group score. What you will do on your own is on the back side of this white piece of paper. So this front side here, this front yellow sheet, this kind of shows you the setup. On the back side, you have 11 questions to answer. These you do completely and totally on your own, okay? This is a lab final. You are doing this completely and totally on your own. Now, invariably someone asks this question. Do not retype the questions. I know what the questions are. I wrote them, okay? Do not waste your time retyping the questions. I have to point this out, or some of you overachievers will retype the questions. Why? I have absolutely no idea. You feel the urge to do that, don't, okay? I wrote the questions. I know what they are, okay? Now, these answers need to be typed, except for the ones that are mathematical in nature. If you don't want to go do radicals and stuff like that on your Chromebook, which some people like to do that, some people find it tedious. I don't care. But, for example, like this first question, how do the kinetic and potential energies of the pendulum change as the pendulum evolves from the source of the razor? Okay. There's that one you would type because it's just an explanation. So if you want to, type it all out, the ones that you're going to type. And then just leave spaces for the ones that you're going to work out mathematically. Okay? And then just write those in. Now keep in mind, this is your lab final. Okay? This is your lab final. I want to be impressed. I want to see the equations that you used. I want to see the numbers, listen to me, with the units, okay? I don't care, like some of you have this religious belief that it's against your religion to write down units. Trust me, I've studied a lot of world's religions. None of them ban you from writing down units. You think they do, they don't, okay? You just don't want to put forth the effort. So, I want to be impressed, okay? I want to see the equation, I want to see the numbers, I want to see the units, okay? And then, as usual, if you're going to do it that way, then put your answer off to the left, put your work off to the right. Okay. You also need to write a short summary when you get done. I emphasize short, 2 or 3 sentences. How did the lab go? What went right? What went wrong? Any last closing thoughts about the class, the lab, the procedure, something like that, okay? Again, 2 or 3 sentences, not a 5-paragraph essay. Hey, this is how the lab went, we did okay. Hey, this was frustrating. Oh, hey, we could have done this better. Something like that, okay? Just a short summary, that's all it is. Okay, so what I need first off back from you is a screen sheet. Basically it says, hey, I acknowledge that if I cheat on this deal and I cut and paste somebody else's answers, I'm going to get a 0 and I'm going to lose a huge chunk of my grade, okay? So that's the first thing that I need back is a simple acknowledgement that says, hey, Urkamp has threatened hellfire and brimstone if I cheat, and bad things are going to happen. Now, I know you're going to work together, but there's a fine line between working together, because you have to, and saying, oh, hey, I'm just going to send you my answers and you can just cut and paste my answers into your document, okay? That's where I draw the line, okay? I know you all have to work together. I'm not disputing that. I just don't want cut and paste answers, all right? That's all. Okay, so let's go to the back and I'll show you how to do the setup and then you'll have a better idea about how this thing is going to play out. Okay, so there's a couple of things about just your setup. So you're going to take a piece of string about yay long, okay? And you're going to thread that through the marble, like so. Now, you want a short side, and then you want a long side, okay? And the short side needs to be about 10 centimeters long. So, I need you to hold that marble. So, what you need to do is tie a couple of square knots. Now, I need you to put your finger on that knot. You want to have somebody hold their finger on that knot because that knot has to be right at the surface of the marble. So, got it? Think you do? You let go? All right. So when you get done, that knot should be exactly right at the surface. You don't want it up above where you get like a triangle and then the razor blade has to cut through 2 strings. So you want to make sure that that knot is right at that surface. So when you get that done, then on the top of this, you want a clamp like this and it has a rod that sticks out. So initially, all I'm going to do is just kind of I can fine tune that height later. All I want to do is kind of get it close so that that marble is about, the top of the marble is about level with the top of the table. It doesn't have to be exact, just kind of close. So just wrap that around like that. Then, guys, can you turn me off a piece of tape a couple inches long? That's good. Thank you, dear. So put that like that. Fantastic. Okay, now here's the most critical thing. So this front ring stand has to be positioned underneath two pieces of board like this. So what you want to do is you're going to have a razor blade which is exceptionally sharp. Okay, be very, very careful with this. And you're going to put this in, slide this underneath like this. And you want about 1 inch of that razor blade sticking out from that edge. Now, here's the most vital thing. You have to cut that ball at the bottom of the arc, okay? You don't want to cut it on the downswing because then it's going to start with a downward projectile. You don't want to cut it past the arc or then it's going to be going up and then you're going to introduce a vertical component. You want to cut it at the very bottom of the arc so basically it turns into a limbing problem after you cut the string. So this is why I say with this top bar that you just want to get it close. So now what I'm going to do is I'm going to move this in a little bit, okay? And then I'm going to twist this and I'm going to raise that marble up so that is just like this. So when this ball is hanging straight down, this is where I want to cut it. So what you want to do is you want to let this marble hang straight down and then set your razor blade. Don't set your razor blade first, okay? Let this hang straight down and then adjust your razor blade so that when that marble is hanging straight down, it's going to come in contact with that. So when this thing comes down like this, it's at the bottom of the arc, that's when that string is going to get cut, okay? That is the most vital thing that has to happen. So when you get that set, and you also want to make sure that you're going to cut that thing exactly at that knot, okay? So I'm going to raise that up just a little bit. So when this swings down, it's going to be at the bottom of the arc, and you're going to cut it right at that point. So set this, then set your razor blade. So when you get that set up, then take a clamp like so, and this isn't like the World's Strongman competition. All you have to do is just kind of hold that snug like this, okay? So make sure that this isn't sticking out over the side so that it doesn't hit the marble on the way down. So when you get that set up, you need to put someone in your group in charge of safety. So if you're not actually lighting this thing, you want to make sure that there's a piece of tape over that edge so in case someone walks by, that isn't like an exposed edge that they're going to cut their hand on. Okay, so make sure you have someone in charge of tape, like someone, like, hey, you're the tape officer. Okay, so then after I get it set up, what you might consider doing, and you'll see this later on, is that a lot of this lab is going to boil down to consistency. So what your group might do is like make a mark on the razor blade, so that way when you reset it, it's going to hit at the exact same spot each time on the razor blade. You don't have to, but the more consistent you are in setting this up, the better your results are going to be. So I've got it all set up. I've got a piece of tape on here. Then what I'm going to do is I'm going to pull this back like this. Can you turn me off like, again, about an inch piece of tape? And then I'm just going to drape this over this end, like so. Thank you. And all the tape up there is going to do is just hold that in place. All right. So at this point, I've got a lot of potential energy. Okay, it's up above the ground. Okay, so I'm going to light this string. and then this is gonna swing down, it's gonna hit that razor blade, it's gonna cut it, and then it's gonna turn into a projectile and go out like this. So what your task is to derive an equation that allows you to measure some distance from the edge of this table, or the edge of that razor blade, out in that direction, and you're going to say, hey, I think it's going to travel 0.75 meters, whatever you think it is. So you're going to measure whatever that you need to measure. One of the things you're going to need is the mass of the marble, but you're going to need it to answer some of the questions, but you'll see the mass of the marble actually cancels out of your equations. Mass of the marble is not going to end up in your overall equation, but you need it to answer some of the questions, so that's why you need that number. So you're going to measure whatever you need to measure: relative humidity, wind speed, the size of my shoe, whatever you want to factor into your equation. It's 11.5. Thanks for asking. So if you can find a way to work that into the equation, all right. So that's going to swing down. It's going to get cut. Boom, it's going to go out like this. Now, because you have to worry not only about distance this way, you also have to worry about alignment. So what you want to be able to do, because thankfully my room was built with parallel lines, so everything is parallel in this room. All the seams in the floor, all the edges of the counters, everything's at right angles. So what you want to be able to do is step back and this is, it's hard to describe, but you'll know it. So what you want to do is step back and close one eye and make sure that these threads here are parallel with the edge of the table, okay? So, and you'll be able to see that. So that's why I said everything in this room is parallel. So I can step back, line up the threads, because I want that swinging parallel with the table. So that way, I don't want it too far out, because then it's going to be on an inward trajectory. I don't want it too far out, and then it's going to go like this. So you want to make sure that this thing falls parallel with the table. So you got everything set up. I gotta get, hold on, I gotta get the ability to make fire. So, when you're ready, so let's say this is an official trial. So, you're going to have a piece of paper on the floor. You're going to call me over and you go, hey, Mr. Burkamp, here's our official trial. Make sure someone takes the tape off of this, okay? Because it happens every year. Okay, someone forgets to tape the tape off, and you light it, and then it's like it's falling, and it's like the Matrix, and you're trying to slow down, trying to think, no! And you can't get to it fast enough, and then everybody laughs and goes, wow, you didn't take the tape off. So, got the tape off, okay? It's going to happen. So then, I want to light this. So, okay, then you might move your foot because it might land pretty close to where you're at. So, you're here. Oh, seriously. Oh, come on. I feel like I'm on a deserted island and I need to make fire. I have made fire. Okay. So we light this. Boom. There you go. So when you get done, put the tape back on. I'm going to go down. I'm going to measure radius from the center of that mark out to the edge of out to wherever that ball lands. Thank you, Jim. Okay. Got the idea. Good? Okay. Back we go. Yeah, it happens fast.
I thought it was gonna be so like firework.
Cool, yeah. Okay. So what I want on your derived equation. So on this part here, on this yellow sheet, okay? So this is what you are actually going to hand in. So you got your name. If your group wants to come up with a clever name, you can come up with some group name. Then this is worth 10 points, that statement of purpose. Okay, this is what you're doing on your own. The problem-solving strategy worth 25 points. This is how I want this started. Okay, so everybody's going to start the same way. You're going to go UG plus us plus KT plus KR equals UG prime plus us prime plus KT prime plus KR prime. Okay? So this is what's happening at the top. This is what's happening at the bottom. Okay? Now, when you derive this equation, you want to derive it in terms of H1 and H2. H1 is the distance from the ball to the floor, excuse me, the ball to the razor blade. The H2 is from the razor blade to the floor. So don't use YH, use H1 and H2. Okay, those are the only distance variables that you're going to use. And then your range, which is going to be how far it's going to go. So you're going to start up here and you go, okay, this is this is what's called a two-column derivation. So this is going to be your initial solvo. You're going to go, this is from, and then over here, you're going to put law of conservation of energy, okay? Which basically just says energy can only change form. Now, up here at the top, you have to figure out, is anything going to drop out? Is anything equal to 0? Oh, us is 0 because there's no springs, okay? And the same thing over here is us prime. So on your next line, you can say, okay, us and us prime will drop out. And then over on the right, so you can say, okay, us and us prime equal to 0. And then over here, say, oh, they're equal to 0 because there are no springs. You can see, oh, KR and K prime equals 0. It's not rotating, okay, so we don't have to worry about that. Now, the whole kicker to this is that you're only going to have UG at the top, and you're going to have KT at the bottom. So basically what you want to do is explain how you end up with UG equaling KT. Okay, that's the basic idea. That's going to be the main part of the line. Okay? Then let's say, for example, you want to use another equation. Let's say you want to use distance equals 1/2 AT squared plus V naught time. Let's say you want to use that equation. Cool. And you can say, okay, that's a given equation. And then let's say you want to solve that for acceleration. Oh, acceleration, you're going to solve this for acceleration. You're going to have A equals da 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 da. And then over here you're going to put solved for A. So basically, as you transition down, you're going to start with one thing, and then if you do something else, if something drops out, if you solve it, if you substitute, you're over to the right, you're just going to tell me, hey, this is why we're doing this. This is the explanation for it. So when you get done, you're going to have all of these steps. And when you get done, at the end of the day, you're going to have an equation that says R equals something. Okay? When this final equation is going to be, what are you going to multiply, add, divide, square root, cube, natural log, whatever. Okay? So when you get done, this equation right here is going to say, this is how we're going to calculate the range from where it gets cut to where it lands, okay? That's what you're striving for at the end of the day. What can you plug in? What are you going to measure? My shoe size, mass, relative humidity, wind speed, H2, whatever. You're going to plug in and you're going to say, this is going to be our range. That's what you're after, okay? That's the ultimate goal. So here's typically how the 3 days play out. I'm done. You have the rest of the time to work, okay? I'm not real picky about what you do with groups, okay? There's 12 of you, okay? Let's have like maybe 3 or 4 groups, okay? I don't care how it plays out, but 3 or 4 groups. And I know there's, you know, Paige is gone, and Bobney is gone, and Ray Gunn is gone. So keep in mind, there will be others that will join in, okay, when you figure out your groups. I'm not real uptight about it. Y'all are big people, figure it out. So typically what happens today, if you can get your equation derived today, that's a cool thing, okay? If you can make that happen today. Typically Monday, that's when you do your trials, okay? Now, if you want to come in before school, hey, I'm here at 6:40, okay? If you want to come in during encore, that's cool. If you want to stay after school, that's cool. Not everybody in your group has to be here for an official trial, okay? So let's say only 2 of the 3 of you were here. That's cool, okay? Not everyone has to be here for an official trial. So typically that's what happens on Monday. Tuesday is crunch the numbers, answer the questions day, okay? Now, listen to me very carefully. This lab, without any exceptions whatsoever, 0, zip, none, maybe a severed limb, but even then that's going to be sketchy, is due by the end of the block on Tuesday, okay? Not later in the day, not Wednesday, not whenever you think you seem it necessary to give me this lab, okay? It is due by the end of the block Tuesday. So bell rings, you hand in what you have done. Not 3 o'clock later in the day, not at the end of encore. This is when this is due. Under no circumstances, short of a severed limb, like I said, that's sketchy. That's when this lab is due. So some of you who question on time management need to be aware of this situation. I am not giving you any extensions whatsoever. I have recorded it. It's going to be on YouTube that I have told you without fail, as YouTube as my witness, this is when this is due. Brookhampton didn't tell us that. It's also printed on the top of this white paper. Hey, here's your deadline, okay? There's no exceptions. Boom. Okay, I'm done. Now, if you want to ask me, hey, Burkamp, are we on the right track? I will tell you. When you get done with your equation, I will tell you if it's right or wrong, okay? I don't want you to do this whole lab with the wrong equation. So when you get done, and if you're not sure, ask me. I will tell you if it's right or wrong, okay? Or when you get done, if you want me to look it over and make any recommendations before you hand it in, it's like, hey, is this good enough? Do we need to tweak anything? I'll do that, okay? Here's the point. I want you all to be successful on this lab, okay? I do. It's a fun lab. There's a little bit of a challenge just based upon, hey, which group can get closest, okay? It can get a little stressful, you know? So, but I want you all to be successful. You have to actually physically make a decision that says, I am going to try to get a C on this lab, okay? Because if you would all do well, you'll easily get a B on this lab, okay? Like if you get less than a B, you have made a decision that says, I want to get less than a B. I'm not going to answer the questions. I'm going to be a slacker. You have made that conscious decision, okay? I set this lab up for you all to be successful, okay? It's kind of it's a cool culminating thing throughout the day. Okay, I'm done. Go, be free.